بسم الله الرحمن الرحيم. به نستعين. اللهم علمنا عنك يا رب وفهمنا عنك يا رب. Learning bioinformatics with ChatGPT. In the previous day number 9, it gave me an activity that I need to read more about the use of single nucleotide polymorphism in personalized medicine and ancestry testing. Okay, so I asked ChatGPT, explain to me more. Okay, I asked them how single nucleotide polymorphism SNPs are used in personalized medicine and ancestry testing. Okay, this means that you can take the lesson and you can dive deep into a specific subject during this journey. Okay, what this mean? Explain to me more. I need more information about this title. Okay, so you can expand the journey of learning according to your interest. Okay, single nucleotide polymorphism SNP play a critical role in personalized medicine and ancestry testing due to their ability to capture a genetic diversity and individual difference. Okay, number 1, he will talk about SNP in personalized medicine. Personalized medicine, it is a tailored medicine, so he step back and identify or define what is already personalized medicine, and it is something I love it with ChatGPT. It defined whatever vocabulary it used. Okay, so it ensures that you flow with him in the study. Personalized medicine is a tailored medicine treatment to individual. According to what? About what you tailored this medical treatment about the individual genetic profile. Okay, SNPs are crucial for understanding how genetic variation influence drug response and disease susceptibility and health outcome. So these specific SNPs, okay, can you give me an idea about this patient specifically? About what? Its response to specific drug, its susceptibility in future to a specific diseases, the health outcome that will be facing. Okay, application. Number 1, pharmacogenomic. What meant? It is drug response. SNPs can affect how individual metabolize drugs, and according to that, how it can response to it. Examples: variation in cytochrome B2C19 gene, it influences the effectiveness of the blood thinner clopidogrel. Okay, so genetic testing help in determining the right drug for this specific patient and the right dose for this patient. Okay, number 2, disease risk prediction. Certain SNPs are associated with an increased risk of disease like cancer, diabetes, cardiovascular condition. Examples: SNPs in breast cancer antigen 1, okay, and breast cancer A2 genes. They are linked to breast and ovarian cancer. What else? Treatment customization. Okay, SNP analysis can guide targeted therapy. Example: HR2 positive breast cancer. What are this? These patients having a variation in HER2 gene. Okay, this variation lead to increase the production of this HER2 protein, which is a receptor, okay, on this type of breast cancer. So we can build on this what we benefit from that using a specific treatment that target these HER2 proteins like trastuzumab. Okay, so what are this? It is a genetic variation in the gene producing HER2, leading to excess production of this HER2 protein in this breast cancer. What we can benefit from this information and this genetic variation in this specific patient, we can target specifically these receptors with a specific drug. Okay. Preventive health care. Individual can take preventive measures by identifying SNPs, okay, associated with disease. Like you can make a lifestyle change, and you can focus on early screening. Okay. SNPs in ancestry. SNPs and ancestry testing. SNPs are also widely used to trace genetic heritage. Number one, it is away from my specialty in molecular biology on medicine field. Okay, but it will not. It is not a loss to learn about a wider usage. Okay, SNP are also widely used to trace genetic heritage and population history. These small genetic variation reveal an individual ancestry and evolution origin. Application. How we can use it? Population specific marker. Some SNPs are more common in specific populations or region. Testing companies. These are companies it compare an individual SNPs to a reference panel of population worldwide and can determine ancestral origin. Okay, maternal and paternal lineages. SNPs on mitochondrial DNA, it is passed from the mother to the child. Okay, so we can trace the maternal ancestry. SNPs on the Y chromosome, it is passed from the father to the son, so we can pass the paternal ancestry. Okay, number 3, admixture analysis. Identify the proportion of an individual DNA inherited from different population, European, African, and Asian. I take this paragraph, okay, I take it a copy and go to my ChatGPT and ask him, explain to me. He said this: admixture analysis is a genetic technique used to determine the proportion of individual DNA that originate from different ancestor population. It helps to understand human migration, population history, ancestral composition. How does it work? Number 1, reference population. Scientists use well-characteristic reference genome from different ancestor group, e.g. from European, African, and Asian. Genetic marker. Specific genetic markers such as SNPs, okay, are analyzed to identify genetic similarity between individual and these reference population. Statistical method. Number 3, computational tool compare individual genome to the reference population using an algorithm like admixture, structure, PCA, principal component analysis. This model estimates the proportion of DNA inherited from each population. Okay, what is the application of this admixture analysis? Number 1, ancestry testing, using service like 23 and MA and Ancestry DNA to provide ethnic breakdown. Medical research, help in understanding disease risk across population, genetic predisposition in mixed ancestry individual. Human evolution study, trace historical migration pattern, admixture event, e.g. Netherland DNA in modern humans. I'm so sorry. Neanderthal DNA in modern human. ايه ده؟ Okay, I didn't understand what is the Neanderthal DNA in modern human. So I continued with ChatGPT. I told him, please explain to me. He said this: who were Neanderthals? Neanderthals is Homo neanderthalensis, were an existent species of archaic human who lived in Eurasia from about 400. 400. I'm so sorry. I have problem in reading numbers. Okay, they coexisted with early modern human, Homo sapien, and eventually interbred with them. Okay, there's theory that how did Neanderthal DNA enter modern human around this year ago, when early modern human migrate out of Africa into Eurasia. They encountered and interbred with Neanderthal. As a result, small portion of Neanderthal DNA were passed down to their descent. Okay, how much we Neanderthal DNA do we have? Non-African population today carry 1 or 2%. African populations no. Some individual may carry different Neanderthal DNA segments, meaning that collectively about 40 to 50% of Neanderthal genome still exists in modern human. Okay, what are the effects of Neanderthal DNA on modern human? Its influence varies trait, including immune system. Some genes help to fight infections but may increase risk of autoimmune disease. Skin and hair. Neanderthal DNA contribute to adaptation like lighter skin tone and hair texture. In Eurasian population, metabolism, some genetic variants affect fat storage and how the body processes food. Health risk, some Neanderthal genes are linked to conditions like depression, allergy, and even susceptibility to severe COVID-19. Okay, this is was a side research about the meaning of admixture analysis. Okay, number 4, in what we are talking in the how SNPs are used in ancestry testing. Okay, number 4, it is migration pattern. SNPs help reconstruct historical migration route and evolutionary relationship between population. Example of SNPs based tool. Number 1, personalized medicine in 23rd and health report using SNPs to provide health insight and disease risk prediction. Myriad Genetic, it offers a test for hereditary cancer risk, e.g. PRCA1 and PRCA2. Okay, according I'm so sorry. Number 2, ancestry testing. Ancestry DNA, it provides ethnicity estimate and family connection. 23andMe ancestry report offer detailed ancestry breakdown and migration histories. Okay, what are the key benefits of using SNPs? Number 1, in medicine, reduce the adverse drug reactions, improve treatment outcome, enable preventive health care. In ancestry testing, it reveals a deep genetic heritage, connect individual to relative worldwide, enhance understanding of human evolution. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.